address of that data type. Now we are saying that we are talking about pointer-like behavior in functional arguments. Like we are saying that variables are reference to an object. When you pass an object to a function, you are passing a reference to that object. What does it mean? That whenever we are going to pass an object to a function, what basically we are doing, we are passing a reference to an object. If the object is mutable, like we are saying mutable, it can be changed, then we are saying that it is going to affect the original. So we are going to see that we are saying that we are going to define a function. Define a function, we are saying that modify list mutable, simply we are going to talk about modify list and list. Then we are saying that we are going to add some function in the list.append. Append mean we are going to add, let's say we are going to add the 4, and the original list was original list was 1, 2 and 3. What we have done, we have append the value. So in append, what we have done, we have just print original list. Original list was comma my list. My list was the original list. Then we are saying that modified list was print then modify list, and that was my list. Done. Now what does it's going to do? It's going to show you that this list is modified. We are saying that this was the mutable list that was pointed like a behavior in the functional argument. Then we are going to talk about multiple reference to the same object. Multiple reference, let's say we are saying that we have A, and A is pointing towards 1, 2 and 3 list array. Then we have B equals to A, but we are saying multiple reference to the same object. Object is A, but multiple references we are going to make. When we are going to make b.append, what does this mean? It will going to append the whole list of the A. We are going to add 4, and then whenever we are going to print A, so A changes are made through B, but it will reflect in A. Then we are saying this print B. What does it mean? The original list was A. When we have printed the A, the A list has been changed because we have made a multiple references towards A. Because B was also equals to A and A was 1, 2, 3, but B had append, B had changed, so both changes were both made in the B, but it is reflecting the changes in the A. Then we are saying that similarly, whenever we have, now we are going to see the built-in function that we have discussed in the previous. We have y equals to x. When y equals to x, we have made multiple references. Then we are going to print. You will see that memory of the x and both will be the same because both are referencing toward the same memory address we are going to access. So for memory access, then we are saying that just print y. You will see that both the memory addresses are the same because both are directing toward the same value. So both, no changes are there in the same. Then we are saying that we have the immutable objects and reassignments. Like we are saying that immutable objects, integers are unable to be modified. We are saying that integers cannot be modified when you perform it. When we are going to perform an operation that seems to change the value of immutable object, it actually creates a new object. For example, we are saying that we have x equals to 5 and just print the id of x. just we are going to print id of x. Then we are saying that if we have x equals to x plus 1, that what does that mean? 5 plus 1 is going to give us 6. Then just print id of x. So what it means, we have created a new value with the value sync memory address, means that addresses are not the same now. Why not the same? Because values had been changed. So we are saying that integers cannot modify. This was the basic